Hello everyone, and welcome back to Technically Unsure, where I'm not really sure what I'm doing technically.
But I know I'm doing it really, really well.
So today we are going to review a different board. It's not one of those, common SBCs. It's actually an FPGA board. So, of course, I'm talking about the ZuBoard 1CG. So this board comes with the AMD's Zynq line of FPGAs, Zynq Ultrascale Plus, MPSoC, and it can be used obviously in wide variety of applications. But yeah, before all that, let me just quickly show you what I'm talking about. So this is how everything arrived. I didn't open any of them. I just wanted it to do in front of cameras. So this wasn't just a regular box. I took it out. This is the power supply I bought. I didn't have to, honestly. I had it, but I just wanted to see theirs, and see how it looks. So in this camera, this is the output. It supports a wide variety, but the board itself supports 15 volt USB-C, and that's the only voltage as far as I know. Anyway, let's put that aside. So this is the board itself. I bought it from AVNet. This is one of the resellers for the development boards for Ultrascale. Okay, let me take it out, and yep, that was easy. And yeah, so let's open this up. All right, store it up, and here we go. Wow, it's beautiful. So this is the board, and there is the battery for RTC. We'll talk about all that. Okay, there's nothing else in here, so let me clean up a bit. Okay, and also I bought this. This is an add-on board. We will talk about that as well. So let me take this one also out of anti-static bag. Okay, so we'll talk about all of this. Yeah, here we go. Okay, let's go back here. All right, so this is the board itself, right? It is, as I said, there's the main SoCs in here, and this is the 1CG variant of the Zynq Ultrascale Plus one, and this is the DisplayPort and eMMC attachment, which you can attach it in here, which we are going to do. And then also I have to mention that this one contains dual ARM Cortex A53 processor and dual ARM Cortex R5F for real-time processor. So let's take a quick look at the I/O, whatever is in here. Let me grab my, where did I leave that? I'll be right back.
2,000 years later.
Okay, so let's walk through here, right? Let's go this way. So in here, this is the 15 volt USB-C power input. So you will gonna connect that to the power adapter to here. This is the USB JTAG and UART connector. This is the USB 2.0. Very underwhelming, yeah, I know, but yeah, this is USB 2.0 connector. Ethernet, gigabit, and micro SD card is in here. So I think that's pretty much on this side. When we flip it over this way, so in here, these two are basically, this is the power button and this is the reset button, and then this is the micro E click side expansion, so you can easily connect the various add-on boards and modules here. And then there are two user controlled programmable basically push buttons. This is SW1, SW3, and there are like 4 tiny red LEDs. Again, these are user controlled at D6, D7, D8, D9, and then we have the 2 RGB LEDs, which are these two, which is D4, D5, and there is also this one. This is interesting, actually. This is the ST Micro temperature and humidity sensor. So yeah, that's that. And if we flip it this way, in here we have these two high-speed GTR expansion ports. Again, you can connect for expansion. You can connect to the various boards. And then what else is in here? Oh, by the way, we skipped these two. So these two are basically switch, right? So the top one from this way, so this is the top one, right? So this one is the boot mode switch, and the bottom one is MIO user switch. So this is user switch, but this is important. This is the boot mode switch, and I actually printed the boot modes here. So let me show you. If you put all to on, it's going to be in JTAG mode. If you want to boot from the QSPI 32, this one is 32, I think, megabyte. I'm not sure. I'm gonna check that. Actually, hold on. I think this was more, 256 meg, I think, flash memory on it. So you have to set it on, off, on, SD card and eMMC, which is with the module, which is this module. So this module comes with a 32 gig eMMC module and the DisplayPort. So DisplayPort, for that I actually bought this one. Yeah, so I'm going to convert the DisplayPort to HDMI, so I can easily connect to existing cables that I have here and connect it to my capture card. So yeah, let's continue where we were. Yeah, we covered all that. Yeah, so this is the high-speed I/O expansion, which we are going to use that to connect the eMMC and DisplayPort connector to this. And yeah, I believe we covered everything. There is also one small right here. Yeah, so there's a pressure sensor over here, and that's pretty much it, honestly. I think we covered everything from what you can see on here. So that's about the I/O. And there is, on the processor SoC chip in here, it comes with like 69 programmable logics IOs and 18 PS multiplex IOs and 4 GTR transceivers. There is RTC, which is backed up with this battery, and you can boot from the 256 megabyte SPI flash, which we talked about in here, QSPI 32 mode, or you can boot from the SD card, or you can boot from this eMMC over here. And generally speaking, obviously this is not for like gaming or daily use or anything like that, right? It can be used for vast variety of projects, right? It can be used for industrial stuff, industrial motor control. The dual core devices are really good for that, and sensor fusion, wired, wireless infrastructure, aerospace and defense, FPGA especially, and even multimedia applications. So this one is CG variant, right? We talked about that, but there is a EV version of it, and that EV one comes with H.264, H.265 video codecs, and it can encode and decode 4K video at 60 frames per second. So yeah, not this one, but the EV variant can do that. Yeah, that being said, before I forget, I paid $159 for this board, right? Development board. And I paid $59 for this and $33 for this adapter, which is totally unnecessary, but yeah, anyway, I did it. And so total price comes down to like $250, right? I paid for all this. And fun fact, I paid $159 for just this development board, right? These are optional. I could have skipped those, right? So this comes with Zynq Ultrascale Plus MPSoC, the 1CG variant. We talked about all that. So you can buy this for $159, develop your application on it, test your application, and design your device and project and whatever you're trying to do. And then let's say you want to go for mass production. This chip itself, just the chip, just the SoC, the Zynq Ultrascale, that will cost you like $500, $400, $500, $600, $700. I saw different prices in different sites, right? Depending on which site you check. How is that possible? Like, it's $160 for this, but the chip itself is, let's say, the lowest one, $400, $500. So the thing is, these are, first of all, to hand it over to developers, and that will be basically a potential real client for mass orders of the SoC, right? So if somebody buys this, develops an application on it, and then they produce a device, some tool, something, right? Then the first thing they're gonna need is going to be massive amounts of that chip. So they are selling this at loss, in quotes, in order to make profit later. You can, kind of compare this to Sony. They say, I don't know how accurate that is, but they say Sony is losing money when they sell the PS4 to PS5, all that, right? Because they hope that you will buy the device and they will make their money back with the PS Plus subscription, with the game sales, and all that stuff that comes with it, not the device itself. So these are called basically loss leader, right? Make the company lose money but lead to bigger projects and hopefully make money for the company. So yeah, here's a business plan for you. Buy thousands of this board, desolder this, and make profit. Yeah, I'm just kidding, don't do that, not gonna work. So anyway, let me power this all up, and then I have SD card prepared for it, and we'll see what we can do with this fantastic board, and I will be right back. Okay, so before I start with the SD card, let's try the built-in example that's burnt into this flash chip that ships with the board, right? Let's try that example. So what I did was I just connected the add-on board right in here for the DisplayPort, and then I connected the Ethernet, and then a UART micro USB connection, which I connected to the laptop, which also I will be recording as well. Then I have the power connection. So the power is going to this power supply, the power adapter, which does also have a display. And let me just show you real quick. Once I plug in this, as you can see, the board is lit up and it is using the 15 volt. It automatically selected the 15 volt. So it is using 15 volts. Now, that being said, let's switch to the laptop. So as you can see here, if I do an ls, let's do in this one, is faster. Ls on the dev TY USB, there is nothing, right? So there is no device, no such device. But if I press the button in here, the one on the bottom, that's the power on button. If I turn it on and if I repeat the same command, you will see that I get 2, right? So in here, if I select the second one, so we did this in the previous video about the UART and UART communications. If you haven't seen it, I highly recommend you go check that out. So what we are going to do is screen dev TTY USB 1, and the baud rate is 115200. So we turn this on, and obviously we lost all the data. So what we are going to do is just reset the board. Let's see. Okay, let's reset the board. It's janky, I don't know. It was working before. Sometimes it works, sometimes it doesn't. Yeah, let me remove the power, reconnect. Search it file, power it on, go here. Okay, as you can see now, we are getting the UART data, right? And it will try to, yeah, it got an IP address, as you can see, 172.16.1.101, and it is running a web server. So these boards ship with this. So it's already built in with this sample code, right? So what it can do is it's actually very few things, but let's go over those. So one, I can read the temperature, which is 26 Celsius apparently, and read the pressure. And then also I can turn on and off the LED, right? So I can set the color. Let's go with the color that's not on the board. Let's go with red and set LED. As you can see, the first LED lit up. Let me show you right there, right? So if I go back here and turn that to green and set it, as you can see, it turned green. And if I turn that to blue and set, that's going to be blue. And if I turn it off, that's going to turn off. Same thing with the second one. So yes, so I turned on the second one. So 2 LEDs that you control, right? So we talked about that before, and yeah, so you can see that those are controllable. And the temperature sensor, I think, is a bit off. Yeah, there's no way the room is 27 here. So I guess, let me remove this, we're not using that. So the temperature sensor is this one, I think. Let me try again. Okay, so let's go back, reboot this, and let's power it on. Okay, let it boot and try again. I think maybe it was getting heat from this one or something like that. Okay, it is up. Let's refresh. Okay, I am pretty sure that's not the temperature, but Okay, yeah, so this is what you get with the built-in firmware, example code, whatever you want to call it. It is on the board. So I didn't install anything. I have an SD card, but as you can see in here from the switch mode, right, I am on, off, on. Yeah, 3 ons, right? So if you look at this, so we are booting from this one, on, off, on. So on, off, on. Yeah. So that's the SPI mode. So we are going for it with this SPI mode. Yeah, so that's the example you get. So now let me turn it off and prepare you for the second demo, which is I'm going to burn some sample image to the SD card and boot from the SD card. I will be right back. Okay, so I switched the boot switch to basically off, on, off, on. That correlates to SD card. Off, on, off, on. So we are on the SD card mode now, and I'm going to remove that for now. And let me just boot it now. So before I do that, let me also prepare the screen command. So yeah, it's not there yet. So let me boot it and immediately run the screen. There you go. So we are capturing the UART connection right now, and there you go. Beautiful. So it is booting into an Ubuntu image that I downloaded from official repo. I will link everything down below. I downloaded the official repo ISO image, burned it into that SD card, and now we are here. So default username and password is Xilinx. So yeah, there you go. We are in. So if we do a neo fetch, might not look pretty in here. Oh, actually it's not that bad. But honestly, UART, I'm not a big fan. Let's switch to SSH. So let's do Xilinx and the IP address. I believe it was 103. Let's see. Yes. See, did I enter it wrong? Yeah, okay, now we're in. So let's make this one bigger and do the neo fetch again. Okay, so PYNQ Linux based on Ubuntu 2204 and Arch 64 with ARM, and the kernel is 5.15. 1 minute ago we booted, and yeah, the CPU is not really detected. So I guess we can run a bunch of, I know it might be stupid, but let's just run a bunch of stress tests and benchmarks. So one example would be the 7Z benchmark. Okay, so first of all, before I forget, let me switch to the root user just in case and install 7zip, right? Okay, that's installed. All right, let's do sysbench maybe. Sysbench and threads. Let's go with guess 8. CPU and run. Okay, let's see how this one goes. See if it's getting toasty. Yeah, not too bad, but okay. So we got events per second is 1182. I don't exactly remember the Raspberry Pi, but I think this is faster. But anyway, this is a number, so just we have that in here. Let me see if I can do stress ng maybe and do it 4, and let's do the matrix thing, right? The CPU method, matrix prod, and matrix brief, and curve, and run it for 30 seconds. Yeah, 60 is too much, 1 minute. So let's do it for 30 seconds and see how it goes. Okay, so we got the results back, and okay, so 102 ops. Not bad, not bad. So as I said, it is not really the point, but I just wanted to show you that. And we are running 5.15 kernel. That's compiled 22. Yeah, and those are the numbers with sysbench number, stress ng number. I think that kind of tells you the processing power of this in terms of CPU processing. And as you saw that Ubuntu is working. Yeah, by the way, there is full-blown APT and everything. It's like full-blown Linux. It's just Ubuntu is working. ARM Ubuntu is working without any problems. Okay, yeah, So I need to do two benchmarks. One is the 7Z benchmark. I just want to see the speed of this 7-zip process. And then I can actually do in parallel because they might not really interfere with each other, but I'm not going to do that. The next test, I'm going to stress test the Ethernet port. I believe it is marked as a gigabit Ethernet. I just want to see if we are going to get gigabit with the iPerf3. Okay, so we're done, and as you can see, I don't know if I mentioned it earlier in the video, but this comes with a gigabyte of RAM, and it used this 7-zip also with 2 threads. So this is the result. These are the numbers for 2 threads, 1 gigabit on this board. Now, very quickly, I'm gonna do an iPerf test, and someone in one of my previous videos actually commented I should do bidirectional. Thanks for that. So I will be doing that. There you go. Oh, it's running. All right. Yeah, I don't think that's a gigabit. So bidirectional, at least, this is 500 megabit. So if we don't do it bidirectional, let's see if that affects it. Yeah, so you get the point. Oh, actually it went back to 5 again. Oh, okay. So from my tests, and this is, by the way, connected with the UniFi original cable, goes to my rack, to my UniFi switch, and then yeah, it's very fast. It's 10 gigabit. So yeah, I'm getting 500, 600-ish, not the gigabit, full gigabit. So it's also running an Ubuntu 22 with a gigabit RAM. So you have to consider all that. And remember, this is not the purpose of this board to install an Ubuntu and do these things on it, but I just wanted to show you the performance. And for now, that's it. Let me try the AVNet examples. If I can find something good, I will be right back. Okay, so I want to show you one more thing, very interesting thing about this board. I just want to quickly show you how you can build your own Linux, put specific apps or make the modifications that you want, and create an SD image basically, and put it into the SD card slot and load it. And yeah, let me show you. So this GitHub repo, as you can see on the screen, is what you are going to need, and there are steps. It's not complicated, and if you really follow the steps, it's going to work. So they say here Ubuntu 18 or 20, so I attempted to do it on a 22. I had to do a lot of modifications, so that was one of the things kind of easy to fix, but I wasn't able to bypass this requirement. I mean, constantly I was getting errors about the boards and supported boards and compatible boards. So if it says Vivado 2022.1, get that. So here is this one. So you just basically come to the Vivado download URL. This URL, just Google download Vivado. And then in here, where versions, you need to switch to 2022.1, this version, and download it. You can download the full installer here, 73 gigabyte, 74 gigabyte, or just download the online installer. And then you need to download the Petalinux 2022.1 as well. I tried to upgrade any of them, and I was just kind of getting a lot of errors. And then you need to clone this repo. So I didn't want to make any changes to my real machine, this Ubuntu machine. So what I did was I just created a virtual machine. So in this virtual machine, I just installed the old Vivado, old Petalinux, and I installed them to my home folder, FPGA subfolder. As you can see, Vivado is here. These are all FPGA stuff, Vitus, and then Petalinux is here. So, and then finally, what I did was I just cloned that GitHub repo, right? So here is the GitHub repo. So what you have to do is you just need to say source, and then wherever you install the Vivado, and then select the, enter the Vivado, and then the 2022.1, and then settings.sh, right? You source and execute that script. And then you have to do the same thing for Petalinux and do the settings as well. Source that as well, run that. I'm not going to run that, I already ran those. And then finally, you just run the build zu.sh from the repo, this repo. It comes with build.zu.sh, this one. You execute that and it does everything, right? So now let's say you want to make custom, U-boot image, or you want to change something in the device tree, or you want to make something different in the file system, right? Let's say you want to put a file in etc, right? What you can do is you can come here. So etc is here. So if you go to root fs, this jam Jammy is actually downloaded through the build zu.sh. So if you say here, let's do gedit, it's easier. So if we open up in the gedit, you can see rootfs file, and it is downloading this rootfs file. I commented it out because it doesn't check that if it exists. So it just, every time it just re-downloads it again. So I downloaded once, and it, as you can see, it puts in the rootfs temp directory and rootfs zip file. So rootfs temp directory is what you see in here. So this is it, the rootfs tmp. So I downloaded once, and then I commented it out, so it doesn't re-download every time. Now what you can do is you can extract this, and I extracted that in here. So this is the rootfs tar gz extracted, and then I went to etc, and then I just wanted to show you something small, right? I just made a small change in the etc issue file. If I can find it, my eyes are not working. Yeah, here. So what I did was I added hello from technically unsure. Today is date and time, and you know, a new line. So I just made the small change to etc issue, and then I repackaged this tab. I went to this folder. I basically opened the terminal, tar cbzf, and you make it one level up. So new one.tar.gz, and you just do store. So you repack the rootfs, and then just make sure either update the build zu.sh, or you just delete the old one or rename the old one and put the one that you created as Jammy AA Arch 3.0.1 tar.gz. So once you do that, then you execute the build zu.sh, and I did that, and it takes a long time. So it takes a long time. It downloads, installs a lot of stuff, configures a lot of things, and at the end of the execution, it creates this img file. So what I did was I just literally copied that and wrote it directly to this SD card, and I just want to show you what happened. So if we go to terminal, and I'm gonna have this ready, and if I power on the board and connect to the, yeah, so as you can see, now it's booting, right? I didn't make any changes to device tree or U-boot, obviously. I just changed the etc issue file, and I added that to welcome technically unsure, whatever. I just wrote something. I just wanted to show you that you can create your own SD image, pack it, create a disk SD card image, and deploy it, and then it will just run perfectly on this board. There you go. As you can see, hello from technically unsure, and today is, yeah. So that's the wrong time, and date is correct. No. Anyway, so this is now working perfectly fine, and this is an SD image that I have created. I just wanted to show you, and hope you enjoyed that. And I will see if I find anything else interesting about this board. Like, I have motor controller micro E add-on board that you can install it in here. I maybe create one video and show you how you can do that to control motors. But yeah, I think this video is already getting long. I just wanted to introduce you to this board if you haven't seen it before. It's a very, very good board for FPGA development. And yeah, thanks for watching. I'll see you in the next video. Bye for now.